This lesson covers Pascal's triangle. We will use Pascal's triangle as a method for quickly expanding binomials. Each row in Pascal's triangle contains the binomial coefficients for the expansion to a different power of a plus b. In the first row, the binomial coefficient of a plus b to the 0 is 0, choose 0. In the second row, the binomial coefficients of a plus b raised to the first power would be 1, choose 0, and 1, choose 1. In the third row, we have the coefficients for a plus b squared. The next row, a plus b cubed. The next row, a plus b to the fourth. And we could keep going as long as we need to. If we write out the values of the binomial coefficients, Pascal's triangle looks like a Christmas tree with ones on the outside. Each row has ones at the beginning and end. And to find values in between, so for example in this third row, if I didn't know I had a 2 here, I could add 1 plus 1. The closest numbers in the above row I will add together. In the following row, in row 4, to get this first 3, I would add 1 plus 2 to get 3. To get the next 3, I would add 2 plus 1. Then in the fifth row, to get the 4, I would add 1 plus 3. To get the 6, 3 plus 3. To get the 4, 3 plus 1. So let's say we want to create another row. We'll start by putting 1s at the outside. Then look at the above row. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So I have the row, which in this case would be the expansion of a plus b raised to the 0, 1, 2, 3, 4, 5th power. Let's use Pascal's triangle to expand x plus 2 to the 4th power. Okay, so here I have my a here is x, my b is 2. I'm going to start by writing the x's and 2's raised to the correct powers for each term, leaving a space for the binomial coefficient. So my highest power of x will be x to the 4th. So I start with x to the 4th and then work down x cubed, x squared, x to the first power, x to the 0 power. For 2, the last term will contain 2 to the 4th. The term prior to that, 2 cubed, 2 squared, 2 to the first, 2 to the 0. So all I need now is the binomial coefficients. I am expanding x plus 2 to the 4th, which will be this last row. And I just plug the numbers into the little spaces I've left, starting with 1, 4, 6, 4, and 1. And then simplify. We end up with the expansion x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. Let's expand 2x minus 3 raised to the 3rd power. Here I will have 2x plus a negative 3 cubed. Okay, so we will start with 2x cubed, 2x squared, 2x to the first power, 2x to the 0 power, leaving spaces for my binomial coefficients. And negative 3 highest power is to the 3rd, so I have negative 3 cubed, working backwards, negative 3 squared, negative 3 to the first power, negative 3 to the 0 power. To find the binomial coefficients, I'll draw a quick Pascal's triangle. Here I will need the 4th row for the 3rd power, which is 1, 3, 3, 1. I'll just put the numbers in the spaces I've left. And we're finished except for simplifying. After simplified, the expansion will be 8x cubed minus 36x squared plus 54x minus 27. Try on your own. Use Pascal's triangle to expand 2x minus 1 cubed.